gonna get started, guys. So I have a calculator ready. Page 69. Expected value. There will be probably one question on the test, minimum one, that will deal with expected value. So usually worth 3 to 4 marks depending on how much work is required. Expected value is an application of probability where we are concerned with the likelihood of either gaining or losing money. And therefore, it will be stated as a dollar amount. Okay, your answer has to be as a dollar value. The expected value is relevant in business, insurance, and many situations in your daily life. Okay. The concept of expected value can be used to determine whether or not to participate in games of chance. This is also important. Determine whether or not to participate in games, right? Or to make a bid for something, and so forth. We think it's always games, but sometimes you can look. I use advertisement, for example. If you've ever seen flyers, you receive flyers, right, in your mailbox, right? Sometimes it's annoying, right? Canadian Tire, I'm just using Canadian Tire, random example. They'll keep paying, cost them a lot of money to print those and get them to you. They pay, right, for that. Sometimes you get a customer that will just chuck it. Like a lot of us will just recycle it, but won't buy anything, right? But others will see it's like, oh, I always needed a compressor. It's on sale now. I'm going to go to the store and probably buy other things, not just the one thing that you came in for, right? So Canadian Tire is like, you know what? We're willing to keep playing that game, right? Spending the money because we're going to get some money back. And in the long run, we will make money, even though it costs us money right now to print the flyer and to get it out to you, right? And they use email, they use YouTube, they use links, whatever, right? They're getting very creative these days. So the expected value is only accurate in the long run, okay? The way we're going to calculate it, it's not accurate and if you just play 1 or 2 times. It has to be in the long run. After playing a game many times, okay? You need a large sample. There it is again, right? The formula goes as follows. And this formula is very different than the one you have on your formula sheet. I would strongly recommend you have this one on your study sheet. I will show you what the one in our formula sheet from the province looks like. I'll just quickly get you to it. There's one section right here. It says expected value. This is it. But this one is not very useful. Look at what it says, gain, right? That a lot of students get that one wrong. Gain is replaced by the price you win minus the cost. So let's say you win $100 with a scratch and win ticket, and it costs you $2 to play. You actually just gained what? $98, right? So my formula is different. And watch this. You can win. There's one prize, maybe the grand prize of like $1 million, let's say. And so there's a probability of winning that and a price there. But there could be a second prize. It could be a second prize of maybe $500, right? There could be ... as many prizes as possible. That's why these dots are there. But at the very end, I want you to highlight this. You have to subtract by the probability of you losing, i.e. not gaining anything, times the cost, right? So this is very important to always have that trailing along. So let's say there's only one prize to be had, one prize, that's it. You go to a social and there's just one prize, right? You buy the ticket, so then everything would be gone. It'd just be that, right? The one prize and then where my pinky is minus that one, right? So this formula is kind of fluid, it's flexible, it according to your needs, right? Let's keep going. We're going to calculate in a bit. We're done in 10 minutes, I promise you. I'm just going to give you one example and then do more tomorrow. You will have to look at the sign and may be determined, it may have to determine what it tells you, right? The sign tells you everything. If it's positive, if you calculate it and you get a positive answer, gain is expected. So it doesn't matter. You get 0.05, like 5 cents, or $150, or $1.25. It doesn't matter. They're all positive, right? We're gonna say it's a good idea to play the game because you're expected to win. Doesn't matter how much, but you're expected to win, right? 0, if you end up with a dead-on 0, it's considered a fair game. You will break even in the long run. Sure, you might win here, but then you'll lose a bunch of times, and then win, lose a bunch of times. You'll break even, so it's your choice to play. I don't think there's maybe one question in all the questions that I've assigned have that, right? Negative, loss is expected. Bad idea to play or invest or put a bid in. So this could be negative, right? 0.25, negative 1,000, etc. Like it doesn't matter. Negative is negative. Okay. So keep that in mind. And just so I don't get sued here, right? Don't want to get sued by anyone. So the value calculated for expected value is the average amount that you're expected to gain or lose per game or bid. And watch this, this is only true in the long run. It will not work out if you only play a couple of games. Okay, so you can't just say, I'm going to play 10 times and then let's see what happens. No, you have to play like hundreds of times, right? And you could be down in the meantime. You could be like losing $1,000 until you finally win maybe a jackpot or a grand prize to kind of even things out. So you don't know if every single game you're going to win, but on average, in the long run, we will calculate whether or not you're going to be winning or losing. So let's go and dive right in. Okay, page 70. One example, okay? A game at a summer fair consists of drawing marbles from a bag. The bag contains 10 red marbles, 30 yellow marbles, 60 white marbles. I don't know if you noticed that, but that's 100. I picked that on purpose. 100 marbles. It could have been 23, it could have been 1,000, it doesn't matter. But I picked 100 just to make it a little easier right now. If you draw a red marble, you win. Okay, so this would be prize number 1. There's one way of winning for sure. If you draw a yellow marble, you win $7. Hey, there's another prize. If you draw a white marble, you get nothing. So this isn't a prize. It's just saying, hey, if you don't get one of these colors up here, you ain't gonna win anything. Good luck, right? Try again, like the Tim Hortons roll up the rim that we're all so familiar with, right? It costs $3 to play the game. I'm gonna use that same color. It costs $3 to play the game. That's what I'm gonna highlight because that is very important. So my first line is gonna be the formula, okay? So expected value is probability of winning the first prize. And then I'm going to go prize 1 minus cost. Because that is technically a gain. That's how much I'm going to gain. Hey, there's another way of winning. So I'm going to go plus. What's the best thing about Switzerland? Anybody? Anybody? I don't know, but the flag is a big plus. Anyways, this probability of winning the second prize. I just want to make sure you're looking forward to being done the course. That's why I throw these jokes. It's like, I can't wait till I'm all done with this. Can't handle it anymore. Okay, probability of winning second prize minus cost. And then I look, is there a third way of winning? And the answer is no. But then you would just continue this pattern. So I go minus, make it nice and visible, like minus probability of losing times the cost. So watch this. I'm going to go highlight the cost, right? Cost, cost, cost. What I'm trying to say here is the cost shows up in every single expression, okay? What is an expression? It's separated by plus or minus. Good old math terms there. Page 70. Let's fill in what we know. And this will come in all different shapes and like it'll be all different kind of scenarios. It could be a spinner, it could be a coin, it could be dice, it doesn't matter. But in this case, it's marbles. So to win the first one, there are 10 red marbles. So I'm going to go 10 out of, could be 1,000, it could be 55. In this case, it's 100. That is the chance of drawing a red one. And I could win 25 bucks. But remember, even if I win it, I paid $3. So I'm really just winning, I'm gaining $22. So there's a, in this case, 10% chance of winning $22. Plus, probability of winning that second prize. How do I win that second prize? By drawing a yellow. A yellow, right? There's 30 of them over 100. Just have to be very careful when you do these, okay? The prize there would be $7. And remember, minus 3 because I paid $3 to play, so I only gained 4. Minus. What's the probability of losing here? This one is not too bad to figure that out. But I keep my denominator the same if I can. So you can probably do the math, right? 10 and 30 are gone already, so that leaves you with 60. That's one way of doing it. You can also just look up and say, hey, there are 60 white marbles, and I'm told that I don't win anything with those, right? So I'm going to go 100 minus 10 minus 30, and that gives me the 60, right? That's the losing part, right? 60% chance of losing there. And just multiply that by 3. Don't go minus, just put in the cost like that. Do you need the formula? No, you don't need to give me this on a test or quiz. I don't require that, but that's, I would advise you to do that, but 25 minus 3 is 22. I clean it up first. I do not enter it just yet. 7 minus 3 is 4. And that's just 3. And now I grab my calculator. Sometimes you need it a little bit earlier, sometimes not, right? So I'm going to go through the motions, okay? Watch how I do this. 10 divided by 100. So whatever number would be here as a fraction, I get it into a decimal. I multiply it by 22. That gives me 2.2. Just warning, sometimes this is you get more decimals than just this. I will ask you to always round to 2 decimals. So this is actually, we're talking dollar amounts here. 220 plus, then I go 30 divided by 100 times 4, that's 1.2. In this case, it's a nice round number. It's a decimal, but you don't have too many decimals. And then you go 60 divided by 100 times 3, and that is 1.8. I'm going to go 1.80. And now you go from left to right. So 2.2 plus 1.2. There could be many pluses, but then at the end you have minus 1.8, and you get a positive answer. See that? It's positive 1.6. So you go expected value is 160. I'm going to put a big plus in front, okay? 160 like that. That would be usually, this could be worth 3 marks right here. This whole thing, getting it all the way to this part. But then you also need to understand what this number represents. So if it says, should you play this game, justify, referring to your answer in A. So even if you get this wrong, you still get to score marks if you answer this correctly. And the answer would be yes. Since the expected value is positive, gain is expected in the long run. Gain is expected if the sample size is large enough. You're expected to gain on average $1.60 per game. So, but you're not going to win $1.60 per game necessarily, but if you average it out, that's how much you would win in the long run. So if you play 125 times, how much would you expect to win or lose? Well, 125 times, multiply that by $1.60, and I have that it's $200. Total gain expected. What I want you to focus mostly on is not exactly how I did this. Don't think they're all going to be exactly the same. I want you to just think through the way I did it. Like, how did I come up with my probability of losing? How did I do that, right? And so remember that. I could also give you percentage. I could say, hey, there's a 30% chance of winning the first prize, 40% chance of winning the second prize. Hey, wait a minute, 30 and 40 is 70, right? That means that there's a 30% chance of losing. So keep that in mind. Okay, what I'm going to ask you is, I'm just going to give you the answer to what's on 71. Okay, I'm just going to go to 71 with me. I won't answer all of them, but just here, 71A, like questions, just write down what the expected value is 50 cents, if you do that right. And I'll give you 72 as well. You ready? So 50 cents. Then you go to page 72. That one has 3 prizes, guys. 3 ways of winning. It may or may not be on the test, something like that. Right? Minus, I put a minus there. Watch for that minus. In this case, you would be losing. Right? So this is page 72A. The expected value here would be minus $3.35. All I'm going to ask you is to do 71 and 72. But I'm going to post more. There are more questions. I'm going to post all of those worked out keys, completely worked out, so you know how to do it if you get stuck. All right. And that's it for today, guys. Thank you.